So number six caused some confusion when you were doing using teams because, you know, solve it after rewriting it in a simpler equivalent form. Well, basically that's what happens as you start solving an equation. You take out some of the complexity a little bit at a time until eventually you're just looking at what the value of your variable is. For this one, I think probably most of you began by using the distributive property. We would multiply um, the 3x and the negative 6 both by this factor of 3. So that would give us 9x, and then 3 times negative 6 would give us a negative 18. There is a plus 5. And on the other side, if I look at it, it's going to be 5x and then minus the number 29. Now, if I simplify the left-hand side I could combine the negative 18 and the positive 5. This would become 9x minus 13, and that would equal 5x minus 29. Probably, I don't know, a lot of things you could do. I might be inclined to go ahead and, let's see, I'll take away 5x from both sides. So if I subtract 5x from each side of this, I do get 4x. And again, this isn't magic. The reason why I can do that is anytime you have uh, quantities that are equal to each other and you take away the same thing from both sides, it always results in quantities that are still equal to each other. So the equality here is true, right, each term because of, first of all, the distributive property. I'm just replacing this with something that's equivalent to it. And then I used the what did I do next? Then I just combined like terms on the left-hand side. Now I'm using a property of equality. I subtracted 5x from both sides. And then I could add 13 to both sides, right? So if I add 13 to both the left-hand side and the right-hand side, we get that 4x is equal to, let's see, 9 minus 3 is 6, and 2 minus 1. So it would be negative 16. And then we divide both sides by 4, and we get that x must be the number negative 4. So pretty sure this is our answer, but always, right, I like to grab a calculator, especially in a testing situation, and just plug this value in. So I'm going to hit 3, and then I'll go times, open parentheses. I'm going to look at the number negative 4. And 3 times. I've got to go 3 times the negative 4. There we go. And then minus 6. And I'm going to close the parentheses and add 5. And when I do that, this side of the equation becomes, and I'll write it up above it, I get that this is the number negative 49. So when x was negative 4, it made the left-hand side become negative 49. Now this is a solution if and only if it also makes the right-hand side become negative 49. So let's go ahead and grab the calculator again. 5 times negative 4. Whoops, I didn't show times a negative 4. And then we're just going to subtract 29 from that. And you can see it did give me negative 49. So this is clearly the solution because it is the value that makes this true. Right? It's the value that makes the left and the right-hand side equal. They're both 49 when x is negative 4. So let's take a look at the next one. This is a great candidate for the method that we call fraction busters, right? And I'm going to go ahead and I'll just go right to it. I'm going to multiply both sides of this by the number 30. Now I want to be real careful. This came up in class on Friday and when we discussed this. When I multiply both sides by 30, get rid of that b. That's problem b. Take a look what we get, right? And this probably is an extra step, but I'm going to show it anyways. My numerator becomes 30 times x minus 5, and that's all over the number 3. On the other side, it becomes 3x times 30 all over 10. Well, there's some common factors here, right? If you look at this number 30 can be divided evenly by 10. 30 divided by 10 is 3. And if you want, you can write it out like this. I don't know that this is necessary, but you could write it as this is 3x times a 3 times a 10. That's the number 30 over the number 10. So you can see there's a giant 1 right there, right? But you can also see when you take 30 and divide it by 10, you're left with the 3. So this numerator, actually the entire right-hand side, becomes 30 divided by 10 is 3 times 3x. It becomes 9x when I divide by 10. On the other side, we can do a similar thing. If we look at here, 30 is divisible by 3. 30 divided by 3 is 10. So this becomes 10 times x minus 5. I can use the distributive property there. That's 10x minus 50 equals 9x, right? Both the x and the negative 5 were multiplied by 10. I'm going to go ahead and take away, I don't know why, I'm going to take away, what am I going to do? I guess I'll take away 10x from each side. So if I subtract 10x from each side, I'm getting my x's all over on one side. I get that negative 50 is equal to a negative 1x. I might even write it like that, negative 1x. 9 minus 10 is a negative 1, so negative 1x. And if I want to know what x is, I could easily multiply both sides of this by negative 1, right? And when I do that, it reveals that x has to be the number 50, positive 50. Now, again, that's my claim that x is positive 50, but again, a great thing to do is to just verify that with your calculator. So let's bring that over again and look exactly what that looks like. So I'll clear this, and you can see I'm going to open parentheses, and inside of there I'm going to put a 50 and then minus the number 5. I'm going to close the parentheses, so that's the entire numerator. And I'm going to divide that by 3. And when I do that, I get 15. So this left-hand side becomes the number 15. I guess I'll write it in red. And the question is that the same thing as the right-hand side? So again, 50 is what I believe x is. So I'm going to take 3 times 50, and I'll press equals, and then I'll divide that result by 10. And when I do that, I also get 15. So 50 is not magic, it's just the value that makes this true, right? When x is 50, we're looking at a very true statement here. The left-hand side is 15 and the right-hand side is 15. Therefore, x minus 5 over 3 is equal to 3x over 10.